In this tutorial, we will look at how we can compare two fractions to determine which fraction is greater. We will be using figures to determine the relative size of fractions. This tutorial is aligned with the Common Core Objective 3.NF.3D. Let us take a look at a situation. Two friends are sitting down and chatting after coming back from a party. One friend says that she had one slice of pizza and is full. The other friend says that she also had one slice of pizza, but she is still hungry. How is this possible? Well, although they both had one slice of pizza each, the girl in the red had a much smaller slice. This is because as you can see in the figure, when you cut a pizza into 8 slices, you end up with much smaller slices. Notice that the girl had one part out of 8 parts. So this represents the fraction 1 by 8. Similarly, the girl wearing the green dress had half a pizza. Let us now take a chocolate bar and slice it into 4 equal parts. Now we know from previous lessons that each slice is 1 by 4th of the chocolate bar. Let us now take another chocolate bar and slice this bar into 5 equal parts. Once again, we know from previous lessons that each slice of this bar is 1 by 5th of the bar. We can see that one slice of the bar on top is larger than the slice of the bar at the bottom. Since each slice of the bar on the top is 1 by 4th of the bar and each slice of the bar at the bottom is 1 by 5th, we can see that the fraction 1 by 4 is larger than the fraction 1 by 5. In math, we represent this fact as shown here. We write the two fractions and put a symbol between them to show which side is smaller and which side is larger. The symbol between the two fractions here is called the greater than symbol. Here are some more symbols that we use in maths to represent the comparisons. One easy way to memorize these symbols is to remember that the lines converge onto the smaller side. So in the greater than symbol, the number on the left is greater than the number on the right because the two lines converge onto the right. Or you might imagine that the symbols look like the beak of a bird, and the beak of the bird is always open towards the bigger, juicier number. We have already seen that 1 by 4th is larger than 1 by 5th. Let us now see what happens if we take two parts of the bar on top and compare those two parts with two parts of the bar at the bottom. We can see from this figure that if we take two parts of the bar on top and compare them with two parts of the bar at the bottom, the combined sizes of the two bars on the top is greater than the size of the two parts of the bottom bar. Therefore, 2 by 4 is also greater than 2 by 5. Let us see some more examples. In this figure, we see 4 separate figures representing the fractions 1 by 2, 1 by 3, 1 by 4 and 1 by 8. If we compare the first two fractions, we see that the numerator for both the fractions is the same, that is 1. However, the denominator of the second fraction is larger, that is 3, while the denominator of the fraction on the left is smaller, that is 2. But we see that the fraction 1 by 3 is actually smaller than the fraction 1 by 2. Similarly, if we compare 1 by 3 and 1 by 4, we find that while the denominator has increased, but the actual size of the fraction has become smaller. In the previous slides, we saw that while the numerator was kept at constant 1, if we increased the denominator, the size of the final fraction got smaller. Let us now check if the same holds true if we take two parts of the fractions and compare them with each other. As you can see here again, we can see that the size of the fraction actually becomes smaller as the denominator becomes larger. That is, 2 by 3 is larger than 2 by 8, for example. So we can generalize this observation into the following fact. While comparing any two fractions, if the numerators are the same, then the fraction with the larger denominator is the smaller fraction. So, for example, if we are told to compare 2 by 5 and 2 by 7, we can see that the numerators of the two fractions are the same, that is 2. However, the fraction 2 by 7 will be smaller than the fraction 2 by 5 because the larger denominator results in the smaller fraction. So, we put the greater than symbol between 2 by 5 and 2 by 7 to represent this fact. Note that the fractions could have been written the other way around. That is, 2 by 7 could have been written before 2 by 5. In this case, we would write the less than symbol between the two fractions. In the previous section, we saw how to compare two fractions if the numerators were the same, but the denominators were different. Let us now try to compare fractions where the denominators are the same, but the numerators are different. In this figure, we see two chocolate bars, each of which is divided into 8 equal parts. Therefore, each part represents the fraction 1 by 8. Now, if we take two parts of the top bar and compare them with 3 parts of the bottom bar, we can see that the fraction 2 by 8 is less than the fraction 3 by 8. And using the mathematical notation, we would write the fractions with the less than sign between the two of them. Let us now take a final example. Here in this figure, we are comparing the fractions 4 by 8 and 6 by 8. As you can see from the figure, the fraction 4 by 8 is smaller than the fraction 6 by 8. And we write the less than sign between the two fractions, as you see here. This makes sense too. If two fractions have the same denominator, it means that each part is of the same size. If you look at the two chocolate bars here, you will see that all parts of the chocolate bar are indeed the same size. Now, if the numerator of one of the fractions is larger, it means that the fraction will be larger because it has more parts. This leads us to the second rule. That is, if two fractions have the same denominator, then the fraction with the larger numerator is the larger fraction. Let us add this rule to the other rule that we discovered earlier. Obviously, if two fractions have the same numerator and denominator, then they are both equal fractions. This brings us to the end of this lesson, where we saw how to compare two fractions. We derived two rules which we could use to compare any two fractions. You should now practice comparing fractions using the Fractions workbook. This is an Android app and is available from both Google Play and Amazon App Store. So head on down to your favorite app store and download the app today. It is free to try. That's it for now. See you again later.